In this presentation, I will illustrate how to calculate the coefficient of constant relative risk aversion in order to find out whether the individual in question is risk averse, risk seeking, or risk neutral. To do this, I will use a real life story which begins with you asking to borrow your dad's car. Your dad says yes, as you were recently put on your car's insurance, but he is unsure about how much petrol is left in the tank, so he gives you £20 and says to fill up the car if needs be. However, as you're about to get in the car, you think to yourself, I don't actually need to go too far on my car journey. Maybe I can just go on my journey, keep the £20 to myself, and hope the petrol doesn't run out. So you decide to check online with your roadside recovery company to see how much it would cost to call him out if you ran out of petrol. Unfortunately, the charge is £100. To make things even more interesting, when you get in the car, you find out that the petrol gauge is broken, so you have no idea how much petrol you have left to run on. So throughout your journey, you are faced with two options: to stop at the nearest petrol station and add £20 worth of fuel to the tank, leaving you with £0, which is indicated by the left option, or carrying on, but each little bit of the journey you go on, the risk of you running out of petrol increases by 10%, which is indicated by the right option. You get in the car and begin your journey, but after already passing a few petrol stations, you cannot cope with the tension of risking being £100 down, so you decide to end the gamble and pay the £20. So the binary choices are indicated as shown here and on the next slide. As we can see, a 30% chance of losing £100 is too much of a risk to you, compared to the 70% chance of getting away with it and the £20 profit. So the calculations in the next three slides will indicate how your CRRA can be calculated from this game. First of all, we use inequalities to indicate that you switch from having greater utility for the risky option to greater utility for the certain option. We then use the algebraic equation as shown to calculate the CRRA values for each option in question. So we have worked out that your CRRA is between 0.1386 and 0.4735. And therefore, from the table below, this indicates that you are risk neutral or maybe even just a slightly risk averse individual, judging by your actions in this game. We have worked out that you are a risk neutral or maybe just a slightly risk averse individual from this game. However, we cannot imply rationality from your risk preferences. This is one of the assumptions for rationality. The second is monotonicity, which in this game's case means that you are only rational if you change your mind between left and right once. And the third assumption is the dominance principle, which requires you to prefer the certainty of £0 over the 100% chance of being £100 down, which is the case here. Therefore, you are considered as a rational player.